So for today, we will have section 3.1, solving linear equations. So we'll have two parts for today's lecture. The first one is uh, the theory and some examples in solving linear equations. And then the second part will be some applications. So we will be working on actual word problems, and we will try to solve those word problems using the concepts that we will learn in the first part. Okay, so what is an algebraic equation? So we begin with the definition of this algebraic equation. Okay, um, if p of x is an algebraic expression in one variable, okay, so this algebraic expression can be polynomial, can be a linear expression or quadratic expression. It can also be rational expressions, can also be complex rational expressions, and even radical expressions. Okay, so if p of x is an algebraic expression in one variable, here the variable is x, then the statement p of x equals 0 is called an algebraic equation. Okay, so algebraic equation is defined, particularly equation is defined by the presence of the relation equal sign. Okay, so we have an expression on the left hand side of the equal sign, and there is another expression on the right hand side of the equal sign. Then what we have is an equation. Okay, so for algebraic expression, what you have there are some products and sums or difference or quotients of variables and coefficients or constants. Okay, so those are the only objects that you will see for an algebraic expression. Whereas you will say you have an equation, particularly an algebraic equation, if you have an algebraic expression and there is an equal sign, and there is another algebraic equation, algebraic expression on the other side or after the equal sign. Okay, now if a is a number satisfying this equation, p of a equals 0, meaning we found some number a, and if we substitute it to x in here and we still have the equality, okay, we say that a is a solution of the equation p of x equals 0. So again, in this equation, x is a variable. It can take any number. Okay, it can have any number. But if you found a number such that when you plug it in, okay, when you plug it in, meaning you replace x with that number and the equality holds, then the number that you got is a solution to the equation. Okay, now if you collect all those possible a's, okay, you collect all those possible a's, and all of those a's are solution to the equation p of x equals 0, then what you have is called a solution set of the equation. Okay, so the collection of all real numbers x satisfying p of x equals 0 is called the solution set of the equation. Now, I want to emphasize that we will only be dealing with real numbers. Okay, real numbers. So there is a bigger set of numbers, but we are not going to discuss that in this course. So all our solutions, okay, all our solutions will only be in the set of real numbers. So there's a possibility that um, you will find a certain number which still satisfies um, the equation p of x equals 0, but that number is not a real number. Okay, there is a possibility that you can find that if you are advanced or if you remember that topic in your previous math courses. So in this course, we will only be dealing with real numbers. Okay? Now, if no real number x satisfies p of x equals 0, okay, meaning we cannot find any real number satisfying the equation, we say that the equation has no real solution. Okay? So the equation has no real solution. Okay? Now, two equations are said to be if equivalent if they have the same solution set. Okay? So in this particular lecture and in the succeeding lectures, we will have several equations which are equivalent to each other. Okay? And they are equivalent by means of this um, statement, meaning they have the same solution set. Okay? But there are times where one equation is easier to solve. Okay? I am introducing the word to solve or the phrase to solve. So there are some equations which are easier to solve than the other equations. Okay? But if these equations are equivalent, meaning they have the same solution set, then we only work on the equations which have easier methods. Okay? So two equations are said to be equivalent if they have the same solution set. Okay? So now the phrase that I just introduced, so to solve an equation, it means to find the solution set of the equation. Okay, so when we say solve the equation, we mean we want to find all the solutions of the equation. So find the solution set of the equation. Okay? Now, when solving an equation, the following properties are helpful. Charan! So first, we have the reflexive property. Okay? So this means for any real number A is equal to itself. So reflexive, it's a reflection of the number. So 1 is equal to 1, 0 is equal to 0, 2 is equal to 2, etc. So A is equal to A. That's the reflexive property. Okay? Now, we have the symmetric property, and this means that if A is equal to B, then B is equal to A. Okay? So if A is equal to B, then B is equal to A. Okay? So you can think of this as, say, maybe Alice and Bob are siblings. Okay? So A, Alice, B, Bob. Okay? So Alice is a sibling of Bob. Okay? And then that means Bob is a sibling of Alice. So if we use the equality to represent that sibling relation, okay? So you can think of that symmetric property that way, okay? Now, transitive property. So if A equals B and B equals C, then A equals C, okay? So if A equals B, B equals C, then A equals C, okay? So let us think of, again, possible scenario. Okay, we again use siblings being the equality here, the equal sign. So maybe we can say A is a sibling of Bob, or Alice is a sibling of Bob, and Bob is a sibling of Charlie. Okay? Then Alice is also a sibling of Charlie. Okay? So they are related by brothers or sisters. Okay? So that's transitive property. Okay? Now, we have the following property here, the zero product property. Sorry for that alarm. Okay? So, the zero product property. So, what is this property? So, if you have the product AB and that product is equal to 0, then either A equals 0 or B equals 0 or both of them are equal to 0. Okay, so if you have a product AB and the product is equal to 0, then at least one of them is equal to 0. Okay, now take note of this. This is a property of the zero product. Okay, this is a property of the zero product. Now, I want to emphasize the following because this is a very common mistake. It's very common to students uh, in algebra and even in calculus or in higher mathematics do this mistake. Okay, so sometimes they will find or you will see something like AB, the product AB equals 1. Okay, then these students conclude that A equals 1 or B equals 1. Okay, it's like they are saying there are no other pairs, okay, that will give AB equals 1 but these two pairs. Okay, take note that this guy here, if AB equals 0, then there are no possibilities, but A equals 0 or B equals 0 or both of them are 0. Okay? If the right-hand side is not equal to 0, say like this, B equals 1, AB equals 1, then there are infinitely many pairs that will satisfy this equation. Okay? So do not do this. Okay? Do not just do this. Why? Because, well, I can take A equals 1 half and B equals 2, right? If you multiply AB, you'll still get 1. Or maybe I can take A equals 3 halves and then B equals 2/3. And if I multiply AB, I still get 1. Okay, so there are infinitely many possibilities for this. Okay, but if the right hand side is equal to 0, there are only 3 possibilities. A equals 0, or B equals 0, or both of them are 0. Those are the only possibilities. That's why this is a property of the zero product. So please, 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 let me remind you, do not do that to other numbers. Okay? This is only true for the zero product. Okay? Question so far? Now, let us move to the next property. We call this the addition property of equality. Okay? So suppose we have A equals B, then for any number C, whatever number C is, you have A plus C equals B plus C. So meaning if you add something on the left, you must add the same thing on the right to retain the equality. Okay, so if A and B are equal, what you added on the left-hand side must be added to the right-hand side so that the equality is preserved. Okay, and then similar to property number 5 here, we have property number 6, multiplication property of equality. So if A equals B, then the product AC equals the product BC, whatever your C is. Okay? Whatever your C is. So meaning, whatever you multiplied on the left-hand side of the equation must be also multiplied to the right-hand side of the equation to preserve the equality. Okay? To preserve the equality. Okay? Question. Okay? So now, you might ask, sir, there is addition property and multiplication property of equality. What about the subtraction and the division? Okay? So let me just give the following explanation. So originally there are only two operators, okay, in this system, the real number system or even in other system. In a mathematical system, we can always define these two um, operations or operators. So addition and multiplication. So what about the subtraction? So your subtraction, A minus B, this is defined as the addition of A with the negative of B. Okay? So if you have a real number B, there's always negative B. You have 1/2, there's always negative 1/2 in the set of real numbers. Okay? If you have 10, you have negative 10. If you have negative 5, you have negative of negative 5. But negative of negative 5, that is positive 5. Okay? So, subtraction is defined as follows. So, A minus B, this is defined as A plus the negative of B. Okay? And similarly, A divided by B, provided here B is not equal to 0. Okay? Provided here B is not equal to 0, this is defined as A times 1 over D. Okay? So if B is not equal to 0, okay, then B will have a reciprocal. You get 1, the reciprocal of 1, it's also 1. You get 2, the reciprocal of 2, it's 1/2. You get 1/2, the reciprocal of 1/2, it's 1 over 1/2, and that's equal to 2. Okay? So you can always get that. So the division can be defined as follows. A times the reciprocal of B if you have A divided by B. Okay? So meaning, subtraction and division, they can be defined using these two operations, the addition and the multiplication. So that's the reason why we don't have those additional names like the subtraction property of equality and the division property of equality, because the subtraction property of equality is already under the addition property of equality, and the division property of equality, it's already inside the multiplication property of equality. Okay? Okay? So now, what we're going to do later is to use this algebraic these properties in solving algebraic equations. Okay? So, for now, let us consider what we call the linear equation in one variable. So, remember the linear expression. Okay? The linear expression is of the form ax plus b. Okay? Now, the linear equation in one variable, say the variable x, this is an equation that is equivalent in the form or equivalent in form to the following equation. Ax plus b equals 0. Okay? So this ax plus b, it's a linear expression. And then we have equals and then 0. So this becomes a linear equation, okay? Where a and b are real numbers and a not equal to 0, okay? A not equal to 0, okay? Of course, the linear equations that we will be working on later in the examples are not written immediately in this way, okay? Not written immediately in this way. So either we rewrite the linear equations later in this form, okay? So that we can solve the linear equation in the original form, okay? And by that, from the original form and rewriting it this way, meaning the original form is equivalent to the form that we will obtain in this way or in this form. Okay? Now, suppose we are able to write the linear equation in this form. So the question is, how do we solve this linear equation? Well, the solution to the equation ax plus b equals 0, where a is not equal to 0, is x equals negative b over a. Okay? So this is the easiest equation to solve. Okay? If your linear equation is in this form already, then the solution will just be negative b over a. Okay? So let me give the step-by-step process from this form going to this form. Take note, this is also a linear equation, except that the variable x is isolated on one side of the equation, and the variable y is, and the constants are isolated on the other side of the equation. But this is still a linear equation. And this equation here is equivalent to this form. Okay? So I mentioned earlier, we will have some linear equation. We will transform it to this form. And then from this form, we will be able to transform it to this form. Okay? But in actuality, when we are going to solve the linear equations that we have, what we're going to do is from the original problem or original linear equation, we will work so that we will go directly to this form. Meaning, we will work so that we have the solution already afterwards. So meaning, we will skip this particular form. Okay? Now, from this form, ax plus b equal to 0, how do we get this x equals b equals negative b over a? So again, I'll show you the step-by-step computation. So we start with ax plus b equals 0. And what we're going to do is to abuse all the properties that we um, listed earlier. Okay? So again, this is a step-by-step process, so do not be surprised. Okay? So we start by adding. So we started from here. What we're going to do is to add or subtract b on the left-hand side of the equation. But the addition property of equality tells us that we should subtract b on the right-hand side of the equation also. Okay? Now, if we look at this, we have, so let us extend that. So we have plus b minus b. We know that this is equal to 0. Whereas 0 minus b, this is equal to minus b. Okay? So these two guys here, Okay, these two guys here are actually um, properties of the number 0 or the negative of a given number. Okay, so these two are properties. Okay, but what's the point? If b minus b is equal to 0, then we'll just have ax plus 0, and then the other guy will just have minus b. Okay, we'll just have minus b. And then again, similar to this property here, ax plus 0, um, it's just ax. Okay, ax, and this is equal to negative b. Okay, now since a is not equal to 0, okay, since a is not equal to 0, then okay, we will have 1 over a. So a not equal to 0, this means that we have 1 over a, correct? This is the reciprocal of the number a. So this one here, it's the reciprocal of a. Okay, reciprocal of a. But more formally, this is known as the multiplicative inverse of a. So multiplicative inverse of a. Okay? Or simply the inverse of a. Okay? Now, I did not mention this negative b is actually called the additive inverse of b. Okay? Negative b is called the additive inverse of b. Okay? But anyway, we have 1 over a as the reciprocal or as the multiplicative inverse of a. Okay? So what we can do is to multiply on the left, okay? Multiply on the left hand side of the equation, 1 over a, and at the same time, so that we can preserve the equality, we have to multiply 1 over a on the right hand side of the equation also. And these two guys here, if you multiply a with 1 over a, that will give you equal to 1. Okay? That will give you equal to 1. So that on the left-hand side, you will just have x, whereas on the right-hand side, remember, I defined division as multiplication, correct? In the previous slide, the division is defined as multiplication of something like this. So the right-hand side becomes negative b over a. Okay? Okay? So again, I have mentioned, this is the step-by-step process. Okay? This is the step-by-step process in solving the equation ax plus b equal to 0 to get x equals negative b over a. Okay? Okay? So, when solving linear equations, the goal is to isolate the variable on one side of the equation by using the properties of real numbers and equalities. Okay? So, we isolate on one side of the equation the variables, and then on the other side, the constants. Okay? And we only do that, we can do that, I mean, by using the properties of real numbers and the equalities. Okay? So, um, let us work on these examples. First example, we want to solve 2x plus 10 equals 7x. So this is not in the form ax plus b equals 0. We have some linear equation on the left and some linear equation on the right. So we want to solve this equation. So we want to solve 3 times 4 minus y equals 2y minus 5. So 3 times 4 minus y equals 2y minus 5. So again, you see there's a variable on the left-hand side of the equation. There's another variable on the right-hand side of the equation. So this is not in the standard form. Okay? So let us solve this. So next example. So we want to solve 2x times x minus 3 equals x plus 3 2x minus 3. So looking at this equation, you will have some linear multiplied to a linear on the left-hand side, and then another linear expression multiplied to another linear expression on the right-hand side. So possibly at this moment, you will think of this, maybe this is not a linear equation. But we will see that this equation here is actually equivalent to a linear equation. So let us do this. So for the next example, we have 2x over x squared minus 4 equals 4 over x minus 2 plus 3 over x plus 2. So now you might be asking, sir, I thought we'll just be doing polynomials or linear equation. Now we have rational expressions. So we will see in the solution that this rational equation here, it's actually equivalent to a linear equation. Okay? So now, this is already the second part of our lecture today. What we're going to do is to work on some word problems. Okay? So we do problem solving. So applied word problems do not come in the forms of the equation. Instead, they supply information using words, a verbal description of the real problem. Okay? Now, to solve such problems or phenomenon, one may translate these verbal descriptions into the language of mathematics, if possible. Okay? So a lot of phenomena in this world are or can be translated mathematically. Okay? Meaning can be written as mathematical equations or mathematical expressions. Okay? This process is called mathematical modeling. So if you are going to the university and majoring in mathematics, there is one whole course called mathematical modeling. So in that particular course, a lot of word problems involved in the real situation will be modeled. Okay? So they will be solved using mathematics. Okay? So this is what we're going to do in the next problems or in word problems. Okay? We are given some situation. Okay? And then we will try to translate it to mathematical equations and etc. So we are going to try to model, to have a mathematical model. And then once we have that, we will solve. We will solve the problem. We will solve the mathematical uh, the equations we have created. if there is something to solve. Okay? So, here are some suggested steps in solving word problems. Very first step is here, and it's very important. So read the problem carefully, at least once, at least more than once. Okay? Okay? Try reading, after reading it the first time, read it again, so you would understand the actual problem or the problem that is given to you. Okay? And then identify what is or are being asked in the problem. Assign a variable to represent the quantity you are looking for. So once you have identified what is or are being asked in the problem, you assign a variable to that quantity. And then there's a possibility that there are other quantities involved in the word problem. Okay? As much as possible, you write all those quantities, all those other quantities in terms of the variable that you already used. Okay? Then, if possible, draw a diagram so you can visualize the situation. And then in the diagram, you label the known and unknown quantities. The known, those are the figures that you will see in the problem. The unknowns, these are the ones being asked. Okay? These are the things that you need to solve. Then, write mathematical statements relating the quantities. You have these variables and other variables and their relation to each other. So try to write mathematical statements out of those relations. Okay? And recalling some formulas and identities may be helpful. So there are times that you have encountered some formulas and it is helpful in the problem, then use that. Okay? Solve the variables or solve for the variables and then answer all the questions being asked. So you solve the variables, then you go back to step 1, answer the questions. Okay? And then check whether your answers make sense in the original problem, not just the mathematical statements you wrote. Okay? Some students do step 6 against step 4. Okay? Take note that your step 4, these mathematical statements, are actually your interpretation of the problem in step 1. Okay? Of course, if you interpreted the problem incorrectly, okay, whether you got the then most possibly your answer, okay, the answer that you will obtain in step 5 will be correct in step 4. But since your interpretation is incorrect, your answer in step 5 will be wrong if you check it in step 1. Okay? So always check the answers that you obtained against the first problem or the original problem. Just like in the checking part that we were doing earlier. You check the values that you obtained in the original problem. Okay? So we will try to use these steps. Okay, we will try to use these steps to answer the remaining problems that we have for this lecture. Okay, first problem. Alice, who is paid time and a half for hours work in excess of 40 hours, had a gross weekly wages of 624 for 48-hour work. What is her regular hourly rate? Again, Alice, who is paid time and a half for hours, work in excess of 40 hours, had a gross weekly wages of 624 for 48 hours work. What is her hourly or regular hourly rate? So next problem, Bob is paid time and a half for hours worked in excess of 40 hours, and then double time for hours worked on Sundays. If Bob had a gross weekly wages of 627 for working 50 hours, 4 of which were on Sunday, what is his regular hourly rate? Car dealer at a year-end clearance reduces the list price of last year's model by 15%. If the new price of a certain four-door model is 8,000, what was the car's list price? How much can be saved by purchasing this model? So a car dealer at a year-end clearance reduces the list price of last year's models by 15%. If the new price of a certain four-door model is 8,000, what was the car's list price? How much can be saved by purchasing this model? So work on as many problems as you can on pages 41 to 42 of the 016 module. So that will be, or well, this is the end of the lecture for today. So thank you for staying.